question number 11, students. In this question, it is given that there is an aluminium sheet of square form and one circle has been cut out from this aluminium sheet, and we need to tell the area of the remaining portion other than, like, after removing this circle, means this shaded portion's area we need to find out. And what is given to us? The side of the square piece of aluminium sheet is given to us, that is 6 centimeter. So we can calculate its area, that is side into side, 6 into 6 is 36 centimeter square. So radius is also given of the circle which we have going to cut from this aluminium sheet. So radius is 2 centimeter given. So for area we can apply the formula pi r square. The value of pi 3.14 and then radius 2 into 2. Now after calculating it, 12.56 is the area of this circle which is to be taken out from the aluminium sheet. Now we need to find out the area of the leftover sheet. So how we can do that? Area of square minus area of circle if we do, so we can calculate the area of leftover sheet. So circle of the area of the square is 36 minus area of circle is 12.56 centimeter square. So after subtracting this, what will be the result? It's 23.44 centimeter square. This will be the answer. Now, of exercise 11.3, question 12 is your homework that you have to do yourself. It's very simple. Now question number 13. In this, a flower bed is there inside a circular garden. Suppose this is the circular garden and this is the flower bed. And the diameter of the flower bed is given to us, that is 66 meter. And the width of this path around this flower bed is 4 meters, the width. Okay, so this is also 4 meter, this is also 4 meter. So if we want to find out the diameter of the complete circular garden, then it will be 66 plus 4 plus 4 to calculate the complete diameter. Okay, so what we need to find out? We need to find out in this question the area of the path. That we can calculate only when we can calculate the area of this larger circle and the smaller circle. So if we subtract the smaller from the larger, we can get the area of this path. So let us start. Given diameter of flower bed 66 meter. So radius of flower bed we can calculate easily by dividing the diameter by 2. So that is 33 meter. So we need to calculate now the area of the flower bed. So for area pi r square, now applying the formula. Now you can see here in the place of pi, I have not put in the any value. Why? Because it is easy for us to solve it further. Okay, I am keeping the pi as same. So just multiplying 33 by 33, that is 1089 pi meter square. I am keeping the pi like this only once. In the last I will calculate. Now diameter of the larger circle. So this is the larger circle. What will be the diameter? I told you 66 plus 4 and plus 4 to get the complete diameter. So that is 74 meter. Now radius, again for radius we need to divide the diameter by 2. So its radius will be 37 meter. Now area, we are applying the formula, but again here I am keeping the pi as pi only. So that is 1369 pi meter square solving. Now area of path we need to calculate. So for area of path, we need to just subtract the area of smaller circle from the larger circle. So now put the values 1369 pi minus 1089 pi. Now pi will remain pi only as we used to do with the algebraic factors like x. Okay, so it is pi only. So if we subtract this from this, the answer is 280 pi. Now we will just put the value of pi 3.14 into 280 after solving 879.2. Now what is the use of keeping pi as it is? Because if we multiply the pi here, we need to put the value 3.14. We'll multiply here also, and then we subtract. So what we did here, we do the multiplication once only with 3.14. So that makes our calculation fast and question easy. So this is the reason. Question number 14, students. In this question, it is given to us that there is a circular flower garden whose area is 314 meter square. And inside the circular garden, there is a sprinkler, okay, that's going to water this garden. And the sprinkler is just spreading the water or sprinkling the water around an area of radius, around a circle, around the area of radius 12 meter. Okay, and the question they asked is, will the sprinkle water the entire area? That we need to calculate. So for that, we need to calculate the area where the sprinkler is sprinkling. Fine. Now, given area of this complete circular garden is 314 meters square. So radius of the sprinkle is provided to us, that is 12 meter. Means in this radius, the sprinkler is just sprinkling the water. So area covered by sprinkler. So that is an area pi r square with which we can calculate. So value of pi 3.14 we have put here, and then r square, radius 12 meters, so 12 into 12. After calculating, we can see the sprinkler can sprinkle the water in an area of 452.16 meters square. In this total area, the sprinkle can sprinkle. Okay, now this area is greater than this of the complete circular garden. Okay, this is the complete circular gardens area. It means it can sprinkle the water in this much area, which is greater. Okay, then this, it means the sprinkler will water in the entire garden. Okay, so this is the solution of question number 14. Now, question 15 is your homework, students, of exercise 11.3, and question 16 we are going to discuss. Now, what is there in the question? There is a wheel given whose radius is given to us of the wheel, and it is given that this wheel is rotating till 352 meters. Okay, the question asked that how many rounds, how many times this wheel has been rotated. Now just try to understand the question. Suppose this is the wheel, and if we rotate a wheel, suppose it is starting from here and I am rotating this, basically one time if we calculate the circumference, that is the one rotation. In one rotation we get the circumference of this circular wheel. Wheel is always circular. So the given thing is total distance covered by the wheel is 352 meter. Okay, 352 meter, and the radius which is given of the wheel is 28 centimeter. So first of all, if we calculate the question, we solve the question, then the unit should be same. So 352 meter, we are converting it into centimeters. So 352 into 100, we need to multiply it by 100 because 1 meters is equals to 100 centimeter. So it becomes centimeter after multiplying it by 100. So this much centimeter. It means the wheel is covering this much centimeters. Now we need to calculate how many rounds the wheel has taken, or how many times the wheel has rotated. So for that we need to calculate the circumference of the wheel, so that we should have we can have the one round distance, means in one rotation how much distance the wheel is covering. So radius of wheel is 28 centimeter. So distance covered by the wheel in one rotation is equals to the circumference of the wheel. Okay, this is the boundary. Now 2 pi r is the formula for circumference. Apply that. 2 into 22 by 7 pi value, and then radius 28 centimeter that we have put here. After calculation it comes out to be 176 centimeter, which is the circumference of the wheel. Means wheel rotated in one rotation this much distance, 176 centimeter. Now number of times wheel rotated. How many times wheel rotated? That is total distance divided by distance in one rotation. Okay, total distance is this much and distance covered in one rotation is 176. So that we can come to know how many total rotations the wheel has made. So after solving we get 200 rounds. So this is the answer of question number 16. Now question number 17 of this exercise, which is the last question. What they have given, the minute hand of a circular clock. This is a circular clock, suppose, and the measurement of minute hand is given to us. And we are considering that this minute hand tip is just touching this circular clock. And now near about this, like going to touch. Now 15 centimeter is the length given, means if we consider that it is a kind of radius of the circular clock which is given. Now it is being asked from us that how much distance is covered by the tip of this minute hand in 1 hour. Suppose in this, starting from this, and how when it completes 1 hour, it just covers this complete distance, this circular distance till here again. We move around this circumference only. Okay, so what we can say, the distance traveled by the minute hand in 1 hour is equal to the circumference of the circular clock, and the radius which we can observe is 15 centimeter. So the distance we need to calculate. Now length of the minute hand which is given to us is, which will be equal to radius of clock, that is 15 centimeter. And the distance covered by the tip of minute hand in 1 hour is equal to 2 pi r, because it is covering the circumference. The distance traveled by it is circumference. So 2 pi r we are applying. So after applying the formula, like 2 into pi 3.14, 15 centimeter is the radius. So after calculation, 94.2 centimeter is the distance traveled by the tip of the minute hand to cover the distance. So this is the end of the exercise 11.3.